Hello and welcome to Meetup number 91 for Beginners Python and Machine Learning. Every week we do a session online, and we used to do it in Fortitude Valley in a meeting room, but haven't been doing that because of COVID. But the online ones, welcome to them. This is the first one for this year. Today we'll be looking at how to do object-oriented programming and how to do some pandas to model the South Australian Tesla battery. My name's Tim Cummings. The format of these classes or sessions, the first Tuesday of every month we do an absolute beginners session for people who've never seen Python before, and on the other weeks we look at slightly more advanced topics, but they are supposed to be for beginners, so feel free to ask any questions as we go. So you can ask questions on the YouTube chat, or you can ask questions in the Beginners Python Slack channel. The sessions I take are more on how to write Python programs, and we have another presenter, Arun, who does more at the machine learning stuff. And so I'll be doing 2 weeks of this stuff, and then Arun will be doing a couple of weeks of his. So to get started, we've got a Google Colab notebook that you can work along with, and I've got a link to that on the Meetup page, and there's also a link on the YouTube page, which you should be on at the moment. So if you click on that link, it'll take you to Google Colab. Now this Google Colab is I'm in the wrong account there. Let's try it in the Pythonator account, and then it'll look like you. So I won't be able to edit it. So you can read it without editing it. So if you want to work along, then you'll just need to save a copy in your own Google Colab account. So we just say save a copy in Drive from the file menu, and you'll see it'll get renamed to copy of Meetup 091 Tim Tesla battery model. Okay. Now if you want, I'll share that hyperlink for this one that I'll be working on today, and so if you get lost with anything I've been typing into it, you can use this link to refresh a copy of everything that I've been typing during today's session. So I've copied that link, and I'll paste it on YouTube, and I'll paste it into Slack. All right, Leo's saying the audio's a bit quiet, so I'll try to turn that up. All right, we'll try going with that. Okay, so the way I'll assume you've used Google Colab before, but if you haven't, just let me know in the chat, and I'll go through some of the ways what you need to know. Today we'll be importing these the standard library. We'll use logging as a standard library, and these third-party libraries. Now, if you're trying to run this on your own computer, and you've got Anaconda installed, then you'll get these libraries. It comes with Anaconda. If you've just got the standard Python install, you'll need to install these third-party libraries, and you do that using pip. So pip install matplotlib and pip install pandas. To run this cell, I can click on this play button in the cell. That'll run it, or you can see I can press Control Enter. Now the first time I run a cell in Google Colab, it's got to fire up all of Python, so it can take a bit of time for the first one, and then other ones after that will be fairly quick. This is a Jupyter notebook that Google Colab's using. When you do using matplotlib in them, you'd often use this %matplotlib inline, and that helps you create plots inline. Doesn't seem to be necessary at the moment, but just I'm used to doing it, so I'll do that one as well. And I'm going to set the logging level to info, and I'm going to use the logging library for displaying results as we go through. So this basic config, that's something that we run right at the beginning. Now I'll try to show you how you do stuff so that it works when you're running a normal Python script, as well as if you are doing it using Google Colab. Alright, so we're ready to get going. So what we're going to try to do today is we're going to get some electricity data from a site called Nemlog, and from that we're going to look at the prices of electricity for every 5 minutes of the month, and we're going to look at the production from the Emerald Solar Farm, and so that's the data we're going to use. So we'll have a bit of experience, or a bit of a demonstration on how that works. It's going to be CSV data, and it's going to have 5 columns. It's going to have a settlement date, the ID of the farm, the regional reference price, which region it's in. This will be in Queensland, even though, but we'll be using data from the South Australian battery. And SCADA value, that's how much the solar farm is producing in megawatts during that 5 minutes. So here's the URL that you can use to get that data, and it takes a bit of time to get the data. So what we'll do is we'll try to store it into a file, and then every other time we call it up, we'll call it from the file. So if I'll run that, and that'll store in those two variables these two locations. As I will store the URL into a variable called URL, and we'll store a file name into the file variable called file name. Now if we tried to read that file, it doesn't exist yet. So I'll just uncomment those lines and see what we get. And you see we get an error, a file not found error, because it couldn't find the error. So we were trying to use the pandas library, which we've imported as PD, to read in a CSV file in that file name. And if we look to see what files are available in Google Colab, you can click on this files icon up on the left, and you can see there's nothing there, just a bit of just a folder for sample data, but that's not the sort of data we want. So let's keep working down here. So what I want to do is I want to read the file name from the file, but if that throws a file error, a file not found error, then I'll go to the URL and grab it from there. So I can enclose this line here in a try block, and then I put an except block to what I should do if I get a file not found, in which case I'm going to read from the URL. So it's going to go to the internet and get the information. So let's run this code here. And you can see it's logged out that the file was not found, so it's retrieving from the internet. So that's that line there, and now it's running this line here, reading from the URL, and that's taking a bit of time, as you can see. So that's why we're not going to do it every time. There we go. So it's got the data now, and we'll look at let's put it into a data frame, and we've stored the data frame in our variable called df. So we look at df.info, it tells us that we've got these 5 columns, numbered 0 to 4. They're the settlement date, the DUID, the RRP, region ID, and SCADA value. And you can see these objects, they're basically strings of text, and these float 64s, they're the numbers. So that's the price, and that's the megawatts. I then did a df.head, which said basically give me the top 5 rows of my data frame, and I can see them here. There's my dates, my IDs of the solar farm, the regional reference price, the region ID, and the SCADA value. Now, on the 1st of, I'm doing this for the 1st of December in 2020, and at 5 minutes past midnight, the amount of solar power we're getting was 0 megawatts, which I guess is what we expect. So what we learned there, we learned how to put lines that are likely to cause an error in a try except, and how to handle that error, do something differently if that happens. If I run this again, I'll still get the same problem because we haven't saved anything yet. So let's just keep working down and we'll do the saving later. Oh yeah, so these settlement dates, they're just string objects. There's just a bunch of text there, which is a bit of a problem because sometimes we want to do things like see how much time has transpired between the first row and the second row, but because they're strings, that will be difficult for us to do. So we're going to use the pandas function to date time that will convert the string to a date time variable. Now, to do that, we say which column we want to convert. We say what the format is, and in this case it's pretty much optional. It's such a standard format that's provided, we could have left that out and it would still work. And then we can say where we're going to save it. We're going to save it in the same column that it came from. So let's run this, and we can see now that settlement date, the data in there is now date time 64. So 64-bit date times, which is storing nanoseconds. So we've successfully converted all those dates and times to date and time, and that's yeah. So now we can do date time arithmetic on that if we want to. The other thing we want to do at the moment, the index is just these numbers that got created 0, 1, 2, 3, 4, and we'd like to set the index to be this settlement date column. So to do that, we can call the setIndex method on the data frame and say which column or columns we want to be the index. In this case, it's settlement date, and that'll return a new data frame which will have that index. And so we'll store that new data frame back in DF, and that will replace the existing data frame with the new data frame with the new index. So let's have a look at what that looks like when we do that. So I'll run that with I was doing Shift Enter. I probably should be doing Control Enter according to that. So and that's given us, we can see now the index is this column, and these are the other fields in our data frame. I put a note up here that if you want to set a in place equals true when you're calling setIndex, you don't have to then assign it to the same data frame. It will just do the change in place in that data frame. Okay, so now we've got the data frame as we want it. We can actually save that to the CSV file with our file name, and we're just using pandas methods here to CSV. We'll just create a CSV file with that data in it. And so if we look over here on the left, we'll see what files we've got, and eventually we should get a file turn up with that file name. So while we're waiting for that to happen, I'll just explain this other form of read CSV. Yeah, so Peter's asked, does in place equal true? Yeah, that's the same as saving back to the same variable. And so what we could have done that here. The reason I didn't do it was just to make it clear that setIndex actually returns a a new data frame, and you can store that in a different data frame if you wanted to. So we could have said df2 equals df.setIndex settlement date, and that means we would have had two data frames, just df and df2. And so if we wanted something in the format of df, we can still use it. We haven't lost it, but we've got everything in df2 if we want to use that as well. But in this case we didn't need to keep the old one, so we've just replaced it, and so the two ways of doing that are pretty much equivalent. In place equals true. I guess if you were doing something like if you were doing this in a function and someone had passed in the data frame as an argument to the function, if you do in place equals true, then the data frame that they passed in as an argument for that function will now have the new values in it. If you didn't do in place equals true, then we wouldn't affect the data frame that had been passed in by someone else into our function, and that's often a good thing, is not to change the data that's been passed into it. Okay, we look in our files over here, we see that file that we've just created, df to CSV, now exists over here in our files list. So now that means we can do a read CSV of that file, and that will work, and we don't have to get it from the net. So I'll just close that and we'll work back over here. So when we read CSV, so remember we had the dates and times came in as text. The read CSV knows that people often want them to come in as dates and times, so we can put in a parse dates argument, and we list here all the columns that have got dates in them as text, and it will parse them into dates and times. We can also specify which we want the index column to be, and that can be either a single column or a list of columns, and that'll do all the steps that we've done up above, but just do it all in one line. So if I run this, I'm using the same variable again, df, so it's going to replace all the data we had in there before with what it reads out of the CSV file. It's going to give us the info from that, which is we've got 4 columns here, text, number, and we've got an index that's in a date time format, and it tells us that that's going up from 5 minutes past midnight on the beginning of December up to midnight on the 1st of January. And there's all the data. So it's the same data as we had before. So that one line successfully did everything that we've done in the lines leading up to it. Okay. So what can we do with this data frame? At the moment we're looking at some data here in the middle of the night, so that's not much use. That's pretty hard for us to work out if things are working properly or not. So let's try to find some values that are greater than 0. So we can create a filter here, and the filter is this bit here, df scatter value is greater than 0, and that'll look through all the data frame and just find out which rows have got a scatter value greater than 0, and actually returns that as a whole sequence of trues and falses. And if we pass that in to the data frame in square brackets, it will just that will then be a data frame with just those rows where the scatter value is greater than 0. That'll still be quite a big data frame, so we can't look at the whole thing, but we can do head to just look at the first 5 rows of that, or if say we wanted the first 10 rows, we can just type a 10 in there and we run that cell. Okay, now you'll see here we've run the this logging line here has run, and it's done the same thing, and it's logged out 5 rows for us because we didn't put anything in the head there. Also in Jupyter Notebooks, we can, if it's something's going to produce a result, we don't have to do print or logging or anything like that. We can just put the calculation that will produce the result, and Jupyter Notebooks will present the result to us. So it's done that here, and in this case it's done in 10 lines, and the format's slightly different, but and it's showing us that 5:30 on the morning of the 1st was when we first started to get some sunlight. We got 0.17 megawatts, 0.47, and then as the sun came up, we got more and more megawatts out of our solar panels. So when you do want to use this feature of Jupyter Notebooks, it's only the last line in the cell that will produce the output that will then get displayed. But if you want several lines in your cell to produce results, then you have to use prints or logging. We've used logging here. The advantage of logging is that we can turn off different levels of logging. So at the moment we've got info logging showing. So anything with an info or higher level, and the levels are info, warning, error, and critical, they'll all show. But if we had a logging.debug that's a lower level than info, that won't show at the moment. Alright, so we've checked our data, and what we're going to do later on when we come to an exercise is I'm going to put all this code in one cell, and you're going to have to understand what each line does and work out which lines to take out and which ones to keep to answer the question. So I'm describing now what all the lines do, and hopefully you'll remember that when we come to the exercise and be able to do this one yourself. Alright, now we want to create a new column in our data frame. So to do that, we just call the data frame name, and then in square brackets we put the name of the new column, and we assign it to some sort of value. So our value in this case is going to be, we're going to take the index, which is a date time value, and we're going to take the hour of that, and we're going to save just the hour in a new column. So that'll be, for this row, it'll be saving 5, 5, 5, 5, 5, 5, 6, 6, 6, 6. Alternatively, we could have used the apply method and passed it in a function, and so it would have taken every row, looked at the row name, which is the index, and taken the hour from that and returned that and put the result of that into the hour column. So this is a really good way of doing it if it will work. So if it's got a function that can be applied directly to the data frame, and you'll find, your simple arithmetic will work, like you multiply and plus and minus and divide, and some of these things like finding the hour of the index, that'll all go straight in. But if you had a more complicated function that you'd written yourself, then you'll have to use something like df.apply and provide the function in here to work on every row in a column. That's right, yeah. So index.hour only works because it's in a date time format. And so let's have a look at, so we want to filter out all the data that we only want to show the rows that have minutes equals 30 for every hour of the first day. So I can do df.index.minute equals 30 as my filter. I can put that in square brackets for my data frame, and then that'll show every row where that filter is true, so where the index is 30, and I'll just look at the first 24 rows, and that will give me just the first day. So this is how I filter out to find the data for at 30 minutes equals 30 for every hour of the first day. So let's see what that looks like. So it's all on the first day, 1st of December. And there's at 0, column 30, 1:30, 2:30, 3:30, 4:30. So we found every line that happened on the half past the hour, and we'll have a look at how much sunlight is producing electricity. So you can see 0.17 megawatts, 29. So as the middle of the day, we're getting more and more, and then towards the end, it's dropping off. And at night time, in the evening, there's no more power generated. And we'll also test that our hour column got calculated correctly. So for this day, it produced the hour 0, then 1, then 2, then 3. So let's put in 48, and we'll see if the hours worked on the second day as well. And yes, they did. 0, 1, 2, 3 up to 23. So that's really useful that we've got an hour column now, because now we can do things that we can average over an hour, or find the maximum value during an hour, or the minimum value. And we can do that by using this group by. So group by will find everything in the column that has the same value of hour, and then we say which columns we want to apply this to, and we want to find the mean of that. So we're going to find mean of scatter values for each hour over the month. So this will create a new data frame. So we'll give this one a new name, and we'll call it df by hour in megawatts. And if we just run that first line there, it's going to have a column in there called scatter value, but we're going to also find the max and the min. So we want to rename the scatter value to say it's the mean, and then we can add extra columns for the max and the minimum. And so we use the rename function of data frames, and to do that we have to pass in a dictionary, and it says what the original name of the column is going to be, and hopefully that's going to be unique, and then what the new name is going to be. And this time I'll use in place equals true rather than assigning it back to itself. So let's run this. So you can see what we're doing. We're calculating the mean, the maximum, and the minimum. We're storing them all in a separate data frame called df by hour megawatt, and then we're going to plot that data frame and see what the data looks like. So there we go. There's the mean is this blue curve during the month, and you can see that on some months it must have been some days during the month it must have been very cloudy, and so there was a minimum of some very low values of production during that month. During those, even like in the middle of the day, it was down at 10 megawatts, and then other days it was up above 70 megawatts when we look at the maximum value. So that plot is a very quick and dirty way of producing a plot from a data frame. By putting it in a new data frame, I could restrict which columns were in it. So we just plotted all the columns that were there, and we've given them the names. So the names of the columns are what's showing in the legend here. I did a plot.show, and that's not necessary in Jupyter Notebooks, but it is useful if you're writing this in a Python script, because otherwise you'll find your plots will appear on top of each other when it eventually does show them. So let's do another plot for pricing. So very similar. We'll use RRP is the regional reference price, and we'll find the mean, the max, and the minimum, and we'll group by hour, and we'll store it in this new data frame df by hour RRP and plot that. Okay, so you can see the prices vary significantly during the day. We get a bit of a so let's see, we'll look at the mean. Well, the mean's just showing so low, and that's because these maximums have just distorted the whole scale of the plot, because they're going up to over $14,000 per megawatt hour at 4 o'clock in the afternoon, and the range there, the maximum's over 14,000 and the minimum is like minus 1,000. So if you're producing megawatts at 4 o'clock in the afternoon on that day, you'd be having to pay $1,000 for every megawatt hour you produce. And so the mean, which is the interesting curve we're looking for, is just been dwarfed by the magnitude of those numbers, so it's just looking like a straight line. Okay, so our next exercise is going to be, we want to plot the mean showing the megawatts, and we want to plot the mean of the price on the same graph. So we can do that in one line here. When we do the group by for the hour, we put here a list of the columns that we want to find the mean for, and so that's the scatter value and the RRP, and then we can just plot those results. So there you go. RRP is this orange line, so the means are not too bad. 4 o'clock shows where things are really go up and down in the afternoon, and the scatter value is showing that curve of when the sun's shining. Now this is okay, but it's really the scatter values are down in this range and the RRPs are up in this range, so and they could have been well different, and so each of their values will be distorting what it looks like for the other. So it'd be nice if we were able to do a plot that could put them on different scales. So I've created a function here that allows you to do that. I'm not really going to go into too much depth with matplotlib, just really showing you what you can do. So in this case, we get the current axis, we can put labels on the plot, and we can plot. So I put this in a function, so it's passing in a data frame. So we're still using the data frame.plot, just like we did before, but we're specifying things like we'd say we want it to be a line or a marker plot where it just puts the dots in. We can say it's what the values are going to be, so that uses the column name. So we're going to plot the scatter value, and we can say which axis it's going to be, just on the main axis, and color yellow. And then we can use things like secondary y equals true, and that says use the second y-axis. So I'll use this as a primary y-axis, and the one over here on the right as a secondary y. And we can say where we want to put the legend. We can say what scales we want to use for those axes, and we can put extra labels on. So let's define that function, and now we can call that function with plot by hour. And you see we've got some nice titles on it. Now we've got the scatter value here is using the left axis, the RRP is using the right axis, and we've got them both showing nicely on the one chart, and that's the hour of the day along the bottom. Okay, so now it's time for you to have a go. What I've done, all the code above, I've copied it down into this one cell, and the idea is that all we want to do is produce that last chart. So you have to go through the code here. So it's going to either read a CSV file or your URL into the data frame, convert the settlement date to date time and set as the index column, add another column to the data frame storing the hour of the day, group the results by the hour, and find the average value for SCADA value and RRP, and then plot those results. Okay, so if I were you, I'd pause the video and have a go at this, and then when you play it up, start it up again, you maybe play it at double time or 1.5 times until you catch up to us. I'm going to keep going, so if you're really lost with what's required here, you can just watch me solve this. Okay, the full code, here we go. We want to set the URL and the file name, and then we're going to read in the file if it exists. If not, we're going to read the URL. Now, we've already worked out later on that this form of the read CSV file, read CSV method, can do extra stuff for us, like parsing dates and setting the index column. So we might grab that from down here, and obviously can't right click, so I'll use Control C to copy and Control V to paste. And I can do that whether I'm reading it in as a file name or as a URL. Okay, now I don't need to look at the info or the first few rows of that data frame. I don't need to convert to date time or look at the info anymore. I don't need to set the index, that's all been done. But it's probably a good idea to save that file name so that next time it'll be cached. So I'll delete all those lines. So saving the file, I only need to do that really if it's come in from the URL. I don't need to do it if it's come from the file name. So I'll indent that, and Python uses indents to work out where the code blocks are. So only these indented lines, they'll only occur if this exception occurred, the file not found error. So it'll only create the file if the file didn't exist. Okay. So we've already used our new form of read CSV. We don't need to log any more results. We don't need to compare min, max and mean for the SCADA value. We don't need to compare min, max and mean for the RRP. We do want to find the mean of production and pricing, and where we can log that out, and then we can plot it. No, we're going to use a better plot. We're not going to use that plot. So we'll call a function that can plot them both. So let's run this. Okay, so I've got the wrong dates in here in the file name, so we need to fix that because I was originally doing it for January, but 2020. But let's do this for December. Okay, and we've got an error. Key error hour. Yes, so we've I've lost the group by line for grouping by hour. So that's this line here. It's got it here, df.groupByHour.mean. Oh, I haven't created the hour column. That's what we haven't done. So we can just create the hour column. df.index.hour. There we go. There's our data and there's our plot. So that's our solution to challenge 1. So if you have any questions with that, let me know. Leo saying had all sorts of problems loading the data file, so ended up mounting Google Drive from Google Import Drive. Yeah, I find that hard to believe that you couldn't write to the file. I'm not sure that these files are actually in Google Drive, Mount Drive. So that will mount your Google Drive. These are just some files that are saved with your Google Colab notebook. And when you close the notebook and come back later, those files will have disappeared. So they'll have to be recreated next time. But if you've mounted your drive, yeah, you might end up with permission problems if you try to save to that drive. I haven't tried that. Okay, and there's our solution. Once again, I've got the wrong month in the file name. But it was useful because it showed us that it would create a file if it didn't exist. Okay, so we've got the file now, which has got all our electricity data, and now we want to model our Tesla battery. And okay, so Leo had a wrong file name also. Were you trying to save it in a folder, or was it just the straight file name? Okay, so we're going to use a Tesla battery, and so basically it can store 129 megawatt hours of electricity, and it can charge and discharge with a maximum rate of 100 megawatts to the grid. We're going to assume there's a 90% efficiency. So if we want to increase the storage level of the battery to 90 megawatt hours, we have to give 100 megawatts of power to the battery for 1 hour. If we want to use the power out of the battery, 100 megawatts from the battery for 1 hour will reduce the storage level by 100 megawatt hours. So we're going to assume all the efficiency losses happen during charging, and the value that's stored in there is the amount that we can get out when we're discharging. We're going to run our battery, so if the price is above $60 a megawatt hour, we're going to sell electricity, and if the buy price is less than $60 per megawatt hour of stored energy, then we're going to buy power. So that way we should make a profit. So the steps we're going to do this is we're going to create a class, and this is where we're getting into object-oriented programming. So the class is going to be called battery, and that's the class is defining what an object is going to look like. So an object can have attributes, so things like current storage level, capacity, charging limit, efficiency, and it can also do things. So it has what they call methods. So we can charge the battery, we can discharge the battery. And when we charge it, it pays for electricity and its storage level goes up. And when we discharge it, we sell electricity and our storage level goes down. Okay. So we're going to, when we initialize our battery, we have to specify things about it, like how big it is, what its constraints are, what its efficiency is. And we're going to need to keep track of those things, so we'll store them. That the capacity doesn't change, but the current storage level, that was what we're going to have to track. And we'll need a method to decide how much to buy or sell. This is a early spec I've done, so we've changed things since I wrote that. And when we discharge, we have to make sure we don't go below 0, and when we're charging it, we have to make sure we don't exceed the capacity. Okay, so class battery, that's Python way of saying we're defining a new class, and it's going to be called battery. And so you would often use a capital letter on the words. If this was 2 words, like if we wanted to call it Tesla battery, we'd put a capital T, ESLA, capital B, and battery, the rest of the word battery. So using title case on the words, we don't have underscores like we do on variable names, because we'll just use the capital letters to work out where each word starts. That's just a convention, it's not required, but if you do it that way, then other people will be able to understand your Python program more easily. Then when we define a class, we should define an init method, and that's got 2 underscores at the beginning of init and 2 underscores after. And this is what is called a constructor. So that'll, whenever we're creating an object of type battery, we'll call this init method. So that's a special name. It has to be called init if you want to use it as a constructor. And we pass into it the things that we need to know to set it up. So we're going to pass in the capacity and the charging-discharging limit. We also need the efficiency, but we'll just default that to 0.9. So we don't have to provide that, but if we want to provide a different value than 0.9, we can override that value. And we store these values inside the object. Now, one thing you'll notice in every function inside a class is that the first parameter is called self. And self is a parameter that looks after, it refers to itself, so the object itself. So in that object itself, we're going to be storing the megawatt hours capacity into a attribute of self called megawatt hours capacity, and similarly for all these other ones. Now I'll go into that a bit more later, but yeah, well, that'll do for now. Right, so that's our constructor. That'll just set up the battery, and then at any time we want to do a charge on the battery, we call megawatt hour charge, and we say how long we're going to charge it for. Now it's going to charge at its maximum rate, and so the maximum rate is basically set by its limit, which is 100 megawatts probably, but we also can't charge it more than the capacity of the battery. So we'll calculate what the capacity is. So that's the capacity, 129 megawatt hours that was originally set, minus what the current level is. So if the current level is 100 megawatt hours, the maximum charge we can put on is 29 megawatt hours. We'll then compare that to what our maximum, if we ran at full limit during the whole duration of, it could be anything, it could be say 5 minutes, and that'll be what the megawatt hours max is, and then we clip our megawatts down so that it's in that range. It's got to charge between 0 and megawatt hours max, and starting with that megawatt hours value. Now, does that make sense what we're doing here, finding out how many megawatt hours we're going to be able to charge our battery for? Once we know that, we can add that onto our level. Oh, I should mention that that's where we put the efficiency in here as well. So I've got the limit is 100 times the efficiency of 0.9. So it's really 90 megawatt limit is how much can go into the battery, as 100 megawatts coming from the grid, and that's for that time. So we've calculated the megawatt hours. We can calculate the effective megawatts of that. We don't really need to know that except for our logging. So we'll just log, so after charging at that many megawatts for so many minutes, the battery level is, and tells us what it is. And we'll just put debug logging on that, so it wouldn't normally show. But if we are trying to debug how our class is working, we can just set the logging level to debug and see what's going on inside the class. So I'll run this cell, Control Enter, and that'll define the class of battery. Now for our first run through it, we will set the logging level to debug. So I'm going to store in a variable what the old logging level was, so I can reset it back later down here, set it back, and I'll just temporarily set the level on our logger to debug. And now this is the code that we're really interested in. We want to create a battery, so we use the class name, battery, and then we provide in the capacity and the limit, and we store that into B. So now if I did a type on B, it would tell me it's of type battery. So I want to find out what the effect on the grid is of charging the battery for 30 minutes. And then I'll do that again for another 30 minutes, and I'll do that again for another 30 minutes. So let's, the syntax is a bit different each time I've done it there, just to show you different ways of doing this, but we'll just run it first to see what happens. All right, you can see here's our debug logging. So after charging at 100 megawatts for 30 minutes, the battery level is 45 megawatt hours. So that's what we'd expect. And so we can say our next bit is saying what happened because of that electricity bought from the grid, 50 megawatt hours. Then we charged at 100 megawatts for another 30 minutes, so it's up to 90. And then at the last 30 minutes, we wanted to charge it at 100 megawatts, but we're going to fill the battery, so it filled up to 129 megawatt hours. So the effective megawatt rate was 86.67. And we bought from the grid 43.33 megawatt hours. So can you see what we've done here? To run a method on an object, we've used this dot notation. So B is the object, D dot megawatt hour charge is the method we want to run, and we pass in a value of a parameter. So it's just like if you're working with a list and you want to append an item to a list, you say the list variable dot append, and you run that method on the list, and it adds something to the end of the list. And that's exactly what we're doing here. We're charging the battery by running dot megawatt charge. So what's really happening though, and this is the second way of writing the same thing, and this is going to really, I've just done this to explain how the self works. So when you write it this way, what Python really does is it goes, well, B was of type battery, so it puts battery out in front. It finds the function megawatt hours charge, and that it inserts one more parameter into our list of parameters. So here we had the parameter 30, and then what it does is it inserts one more parameter, being the object, which gets put into self, and then the 30, which gets put into duration minutes. And so that's how, where we've put B there in our method, that B is really self. And self, it doesn't even have to be called self, you could call it something different, but I recommend you call it self so that everyone understands what you're doing. In fact, the syntax checkers will actually go, you really should be calling that self. And so it's really saying B dot megawatt hours capacity minus B dot megawatt hour level is the number of megawatt hours that we can charge by, and it looks at B dot megawatt limit. And so everywhere you see self, it's really just substituting in B. So if we had another battery, say C, it would, and we ran megawatt hours charge on battery C, it would substitute itself in there with C everywhere. And finally, another way of calling this method is using a named argument. So we defined the function up here with duration minutes as a name, so we could say duration minutes equals 30, and that's the same as just providing one positional argument. How are we going? Have I lost anyone yet? If you feel free to ask any questions about any bit of code that we're working through. Okay, so challenge 2 is create a method on battery class for discharging. All the efficiency losses are to be modeled to occur at charging. Okay, Peter likes this. That's good. All right, so what I'll do, I'll take very good. We're going to edit battery, and this time we're going to create a method for discharging. So it's going to be pretty similar. So I create the class battery here, and this will just override the previous definition. So we're going to create a method in this class called megawatt hours discharge. It's going to be in the class, so we'll start off with self so that we can call it on our instance variables of the class, instant objects of the class. And we'll use the same parameter, duration minutes, and then colon to say we're starting a function. And then you see it automatically indents after we put a colon at the end of the line, and we're indenting 4 spaces. So we want to look at the megawatt hours for discharging. So we can't discharge more than the current level is, because then it'll take it empty. So megawatt hours is really self dot megawatt hour level. Then the maximum rate that we can discharge is, once again, it's megawatt limit, but we don't have to worry about efficiency because we're modeling all the efficiencies just on the charging, not on the discharging. So the class is declared here. That declares the class. One thing you can do with object-oriented programming is you can inherit from a previous class, in which case you'd open parentheses here and put in the other class names that you want to inherit from. But we're just creating a class from scratch, so it'll just inherit from object by default, so we don't put any parentheses in there. So we just create class battery, and that defines it. We've defined it earlier, so this is actually redefining it as a new class. And so I've left all of these in it, and megawatt hours charge will stay in there. We want to make sure that our megawatt hours is between 0 and megawatt hours max. Now, when we do discharge, we want to change the current level. So let's just copy all these lines. So we're going to reduce the level here. Before we were plus equals because we were increasing the level. Now we're going to minus equals to reduce the level. The megawatts that are going into the grid, that's the rate of megawatt hours change. Doesn't have any efficiency correction at this stage because this is on the discharge. All the efficiency is taken up in the charging. And here we'll put in a logging message for it. After discharging, add this many megawatts for this many minutes. The battery level is that, so that's all the same. And then return the megawatt hours sold to the grid. And once again, we don't have to worry about efficiency during discharge. So if I do Control Enter on this cell, that will redefine this class. with our new megawatt hour discharge. Now if I look at the solution that I provided here, I actually created this function outside of the class definition. So you wouldn't normally do it this way. You normally do it the way that I've done up here, but it means that you can change class definitions on the fly by creating these extra functions. And then to put that in, I've just said battery.megawatt hours discharge equals megawatt hours discharge. Okay, now because I've redefined battery up here, this is actually not going to work. I mean, it will work, but it won't affect our previously created battery. So we've created a battery on the original definition of battery, the original class definition, so it doesn't know about megawatt hour discharge yet. So what I'm going to have to do is I'm going to have to recreate our battery and charge it up. So I'm going to rerun this cell up here. It should run fine. We haven't made any difference to the charging, just to the discharging. Yep, that all charged the same way. And now if I come down here and try running, I'm going to set the level to debug, and we'll try discharging, and we'll see what it does. So yeah, it started at 129 megawatt hours because I just recharged it. 100 megawatts at 30 minutes, so that went down to 79. So it sold 50 megawatt hours to the grid. Then we did another 100 megawatts, went down to 29. And then we did 58 megawatts for half an hour, which was the maximum rate, and that took out the last 29 megawatt hours of the battery and left the battery at 0 megawatt hours. So that's working. Let's just have a look at this code here. I've got 4, and I've used a variable name underscore, which is basically saying I want a variable, but I'm not actually going to use it anywhere. So I'll just give it the name underscore. I could have put a variable name in there, but you'll see people doing this occasionally. They'll just they just want the loop to go around 3 times. They don't actually care for having a variable that says what time through the loop it is. So we're just saying I'm not going to use it, so I'll just put underscore there as my variable name. And I set the level to debug so I could see these debug statements, and then I set it back to info, so that when I run other cells, it's just not affected by my temporary change. All right, so to the class battery, this is our next challenge. Add a method, megawatt hours decide, which takes parameters RRP, RRP break, and duration minutes. And above this break price, the battery is going to charge. The battery will discharge, and below it, it will charge. That makes sense. Because of efficiency losses, there will be a range of grid prices where the battery will not charge or discharge. So RRP break is actually the price, the effective price for megawatt hours in storage, not the price we're paying from the grid. So we have to apply efficiency to that to work out what the effective price is. So to define a function in Python, you all know you use a DEF to define the function. We're going to call the function megawatt hours decide. And it's going to take parameters. Now the parameters, I'm going to have to add a self in there because I want to use this in my class. And then the parameters I want are RRP, RRP break, and duration minutes, and colon. Okay, so if the RRP is greater, well, if the, so what we'll do first, we'll do discharging. So if RRP is greater than RRP break, so this is a challenge, so you can have a go at this. As I say, pause the video and try this yourself. But if you want to just watch me solve it, then you can just listen along. And we want to calculate how many megawatt hours it's changed. So we'll store that. We'll run the discharge function that's in battery. And discharge, we just have to say how long it's discharging for, and it'll work out the maximum rates that it can do that for. Alright, else if, so if it's not the first one, then I'll do another condition, and so I use elif. If the RRP is less than, now what I actually want is the RRP divided by the efficiency, because that's the effective cost of putting storing stuff in the battery, and I want to check that that's less than the RRP break. Then I'll work out the megawatt hours that is going to be charged. Now these megawatt hours that I'm working on, they're going to be used for calculating the profit. So if I'm charging the battery, I'm spending money, and if I'm discharging, I'm making money. So I'm going to put a negative sign out the front of this, because that's going to cost me money when I'm buying those megawatt hours, and when I'm discharging, then I'm making money. All right, so if it's could be a time when neither of those conditions are true, in which case we don't want to charge or discharge, so we'll just set megawatt hours to 0. All right, now let's in our battery we'll store how much our profit has changed because of this purchase or sale. So I'll just say plus equals the number of megawatt hours times the RRP. And we'll return those megawatt hours. In case somebody who called this function wants to know what the megawatt hours were. Alright, so that's my function, and I can use this clever technique for adding it into my class definition, saying megawatt hours decide equals megawatt hours decide. So this megawatt hours decide here, that's this function we've just defined, and this megawatt hours decide, that's going to be the name, it could have been a different name even, that's going to be called inside our battery class. So I can run that, and that's put that function in there. Let's look at the solution. Solution's pretty similar. I've done a divide. In the solution we've done a multiply. Should be the same effect, and we've got a logging statement in here. So it's an interesting logging statement I put into the solution. Sometimes, so logging level of debug is basically log level 10. Logging level info is logging level 20. Now sometimes I want to put in an extra logging level in between those two, because I don't want all the debug logging, but I want more than the info logging. So I can create my own levels. I recommend don't do it much, but in this case it was useful to do. So I've created one at level 15, and that'll so I don't have to turn on debug logging, but I can turn on just an extra to get this grid change logging. So let's run that. I'll use as a solution one, which has got this logging in there, and let's see. So if I get my logging, I can set the level to 15, where before I was setting it to 10 or 20, and then afterwards I'll put it back to the old level, and we'll try different prices and just see what the battery is going to decide to do based on those prices, and so the price being, we've got our price here, it goes into RRP. 60 is going to be our RRP break, and 30 minutes is going to be our duration minutes. Okay, so here's our battery. We just got logging level 15, so you can see we've missed out on all our debug logging at level 10. Price is $30, so we're going, let's buy at 30, we'll buy at 40, we'll buy some more at 50, and the price gets to 60, which is right on the break anyway, but we're full, so we can't really do anything. At $70 we go, yep, that's high enough, let's sell. We'll sell. At $90 we go, we'd love to sell, but we've run out of charge, and so we can see that the level's gone down. We've got here profit. You can see it went down as we were buying, went up when we were selling, stayed up when we weren't doing anything, and then when we started buying again, it started going down. It says a negative profit at the end. You've got to remember that we started off with an empty battery, and we've now got a full battery. So as along with our $1,300 of profit, we've got a full battery that we can sell at any time we want to. So that's not actually the profit, but that's the difference between all our payments and our receipts. Okay, so Leo's asked, does self carry in it to megawatt hours charge? So what really happens when you create a class of battery with this init here? Init is what gets called when you run this line here. Oh yeah. That line there, that's the one that calls init. So B equals battery, it creates a new object of type battery, and then we've passed in some parameters, so it goes, and it's got these parentheses there, so even if we didn't have parameters, it goes into here and goes, this self here will now be what is the value of B, and we'll set these attributes to the value to the object B. So B.megawatt hours capacity has got that value, B.megawatts limit has got this value, and these came in from our parameters that we passed in, and the efficiency also came in through the default parameter, and the levels that got initialized to 0, and the profit got initialized to 0. Now I can look at those. Where are we? Yep, so I'll create a new cell, which is Control M below, B for below. Now if I look at B.AUD profit, it's telling me 1356. So I can look at any of those attributes that got set in B. And so B.megawatt hours level, I can look at that. And that's a value 129 megawatt hours, so it's telling me my battery is currently full. And I can also look at megawatt hours charge, and that's, so you see I haven't put the parentheses here, so it's just telling me what is the attribute B.megawatt hours charge, and it's a bound method or a function of battery. So I could have looked at it that way, or I could have looked at it this way. And so that's telling me it's a function, and so using the B notation, it was actually telling me more information, which was that it's going to battery.megawatt hours charge, and because I haven't overridden it for an individual instance, it'll just be using that that one that's defined, that attribute that's defined when battery was originally defined. But we can replace functions even on individual objects, but you normally wouldn't want to do that. But does that explain how self works? So I'm trying to understand your question. So self carries the init to megawatt hours charge. No, so the init is what sets the attributes for the object, and megawatt hours charge uses those attributes from the object, is probably a more correct way of saying that. Okay, challenge 4. Use the data from Nemlog to calculate the profit possible over a month. So we're going to loop through the data frame prices RRP and decide whether to buy, sell, or hold and calculate the profit. So this is good that we can turn our logging level down a bit, because we don't want to be, there's a lot of intervals during the month and we don't want to get logging for every line that happens. So we can, we've got all our data is in a data frame, DF. So we could just go for price in DF RRP. And we're just going to call the decide method. On that price. And we'll set the RRP break equals to $60. And we know that the duration in minutes is 5 minutes on each of those intervals in our data. And then we just find out what the profit is at the end. And so that's saying that we come up with $731,000 profit from running over the month if we just break at $60. So above $60 we're selling, below $60 we're buying. Yes, so Leo's correct. The init does the initialization when we create the instance. So B is the instance of that object, of that class, and it's an object of the an object instance of that class, and so init initializes it, and it creates. You can have class attributes and instance attributes, and which you can have and the functions fall in that same category. So if you don't override a class attribute, then every instance will be looking at the same attribute, but then if you override it, then that particular instance can have a different value. So for example, we could decide that when we just defined our battery class, all batteries were going to get the same efficiency of 90%. We could just put that in as a class attribute, and then so let's put in. Well, I don't want to change my, because I've got data already in there, but what I can do, I'll do Control M below, create a new cell. I want my battery class, and I'm going to set a manufacturer equals Tesla, and then I'm going to look at the manufacturer from B, and it comes back as Tesla. So b.manufacturer is looking at the attribute manufacturer, but there's no attribute actually been set on the object B. So what it does, it goes back to its class definition, which is battery, and returns what the value there is for the manufacturer. So if I change that to ever ready. And then looked at B dot manufacturer, and also looked at the battery dot manufacturer. You can see now that my instance value B has a manufacturer of ever ready, but the original class has still got an attribute of Tesla. So any new batteries that get created, they'll all have Tesla as their manufacturer, unless they override it with a value that's just for that object. Okay, so Leo's asked, I can have A equals battery, that should be battery with a capital B, and C equals battery with a capital B, and yes, so each of those will have different values in it. When you call that constructor, they'll store different values in there. So let's try an example of that. A equals battery, and we'll make this one a bigger one, 258 megawatts, but it can only go at 50 megawatts a time. And then we want to look at those values. So we've created a new battery. This one can do everything, but it's can store more charge, 258 megawatts, but can only has a maximum rate of 50 megawatts. So if we want to look at those limits, we look at A, the limit is 50, and we look at B, and the limit is 100. So each one of those is called the init when we call this constructor. That's what calls init. And we can call charge and discharge on either of those, and they will work differently because they've got different values for limiting for their limits and their charge capacity. All right, so let's look at the solution for our challenge. So we could have done this quick solution here, and even in the quick solution, I did the extra quick solution, so I didn't even reset my battery. So my battery started off fully charged because that's what it was in our previous example, and then just used all that data, and so it made $731,000 profit. So I could have reset those values, set the profit back to 0, set the charge value back to 0, and then run that loop, and then logged out the result. Alternatively, I can do it this way, so I can create a new battery with the same settings. I'm going to store this one in battery variable, and I'm going to find out how much megawatt hours I've bought or sold at each part of each iteration through the loop. So this time I'm using a loop variable because in fact I did last time as well. So I'm using the loop variable index to get the index at RRP, and then I'm setting whether I bought or sold. So if I've bought it, then I've put a flag into a column called buy, and into this one's selling. I put this value into sell. I put this value into buy, and then I can plot these. This is going to make more sense once I plot it. So let's have a look. I'll run this one. It's $727,000, so it's a bit less than the $731,000, which included previous profits and previous charging. I can look at the first few lines of my data frame, and you can see I've added these extra columns in here, what the current level is, how much profit I've made up to that time, whether I've been buying or selling. And I've put in here a method for plotting. So let's have a look at that. If I plot the battery there. So this this is showing how to do two plots on the same output. So I've used subplots to do this. And this is the battery level. You can see it stays up, and then when the price shoots up above 60, then it's the charge comes down. So all these red dots are where we're selling, and all these green dots are where we're buying, and this yellow is the fluctuations in price throughout the month. And so you can see that's how we're buying and selling throughout the month and making our money. Okay, so that's really all the material that I had for today. What we're going to do next week is look at how to optimize and work out what the best price is to buy for our break price, and we're going to use some trial and error or optimization methods so that we can do that. Now Leo's just asked another question. How can you share a class across multiple files? Okay. So if you, I would generally keep as much of a class in a file as possible. And in fact, in Java, when you're doing object-oriented programming, each file is a class. So it's every Java source code file is just about that object, and you create all the methods and the variables and inherit from there. So if you're wanting to split it across multiple files, you can do things like I've done in this, because each one of these cells could be considered a separate file. And so that's where I was doing things like battery.megawatt hours decide equals megawatt hours decide. So I can have one set of functions that I've put in one file and another set that I've done in another, and then at the bottom of each I would have to do this sort of line for each function that I wanted to add into the class. So it's a bit cumbersome, but it is a way you could do it. Another thing you can do is you can rely on inheritance. So for example, you might have different sorts of batteries that have got different characteristics. So you can create a base class and put that into one file, and then in another file you create the subclasses that inherit everything from the superclass, plus you adding in extra methods that define exactly that behavior for this particular class. And so you can add extras, or you can override particular behaviors. And to do that, to get the other class to get the base class visible in your file for the subclass, you use an import statement to import the base class. So does that answer your question? So thanks everyone for following along. I'm trying to get up to 100 subscribers so that I can get a decent channel name on YouTube, but they're not going to let me do that until I get enough subscribers. So if you feel like subscribing, that would be great. If you feel like clicking on like, that would also be great as well. I'm just waiting to see if Leo's got any more questions. Thanks, Peter, for staying with us. Yeah, so how do you help promote the channel? If you get people to, I don't know, you can get the channel already. Do you want me to give you the old channel name, the current channel name, which is really complicated? And I'll post that onto Beginners Python on the Slack channel, and you can tell people to visit my channel and subscribe to it. But once I get to 100, and I think I'm about 70 at the moment, then I can give you an easier name after that, and that's all I need. I'm getting some very positive comments at the moment for my Python macros in LibreOffice. So a few people realize that that's it was a really good resource. I put a lot of stuff together on that and there's really nothing else available that helps you write Python macros in LibreOffice. So I think that was number 87. So that's been my most popular one so far. If you import a file, can you import its classes? Yeah, if you import a file, you can say from a file name import the class name, and that will import just the class that's in that file, or you can import the whole file and you'll get all the class definitions then. But if you import the whole file, then you have to refer to those classes with the file name dot the class name. So it's probably easier to say from the file name import the class name. Okay, so these files are all up on the session summaries. I think I put a link to that right at the beginning. Collab YouTube. No, there's no link there. But anyway, it's there's the URL, github.com /session-summaries, and we're in the online folder at the moment because these are all the ones we've been doing online, and it hasn't arrived yet, so let's refresh. There it is, Tim Tesla battery model, and this is a Python file, so it's slightly different to the Google Colab. But if you're wanting to see how to run this stuff as a Python, yes, yeah, next project is the subscriber bot. Yeah, so the next project will be next week we'll actually be doing optimization of our Tesla battery. But yes, that's a good point. We could try to do a subscriber bot. I'm not sure how much Google will appreciate that. Yeah, we would need to create separate Google accounts for each subscriber. So yeah, that's probably not going to work. Okay, thanks very much. See you next week.